in this problem, we are using what we know about similar figures in order to figure out what the perimeter of the smaller triangle needs to be. So there's one thing, even if you forget how to solve for the missing side lengths, we can at least know what our answer choices could be if we look at it from this perspective. I think we can all agree that this triangle right here is smaller than KLM. So KLM, if we look at the perimeter of that, that's going to be 12.5 plus 7.5 plus 15. So the perimeter of this is going to be 35. This other triangle is smaller. So at this point, I can roll out 35 and 71.34, or 71 and 3/4. Sorry. Now, of these, maybe I can't decide from there exactly what it should be, but let's kind of see what to do. So if I've got, let's see, if I've got corresponding sides, then what I can do is I can set up a proportion. And that's what we did before when we were looking at similar figures. So 3 over 7.5, those are corresponding sides in similar triangles. That's going to be equal, if I call this x and y, then that's going to be the same as x over 12.5. They have to be proportional. They grow by the same scale factor. So when I do the cross products on this, I'm not going to do the math, but the cross products on this makes this one 5. Okay, so now I could find out that this is side length 5. Sorry. And then if I wanted to solve for y, I could set up another proportion. So the same one, 3 over 7.5 equals y over 15. And then again, doing the cross products, we can get y equals 6. So now we can just do, that's 6 right there. 3 plus 5 plus 6 is 14. Another thing we could do, since we already found that the perimeter of the big one is 35, the perimeter grows proportionally as well. We didn't talk about that, but maybe you have that idea in your head. So 3, 7.5 will equal the perimeter of the small one over 35. And when we do that math, we're going to get x equals 14. So regardless of how you approach it, there you go. You can figure out what the scale factor is going to be. So that was just mentioned in the chat. So what we have is the scale factor of 2.5. And that's another valid approach. So enough about that problem. If you didn't get it right, hopefully you can see your mistake. And if you got it right, good for you. All right, we are going to move today into volume. We started learning a bunch of area formulas, and I mentioned along the way that you're going to continue to use those area formulas, so don't just forget them. And today when we're learning the volume, it's kind of, you take your area and you do one more calculation to it. And then you've probably solved for volume in the past anyway, so this isn't going to come from out of nowhere, but we will need to make sure that we know how to use these volume formulas. So when we say the volume of prisms and the volume of cylinders, these are essentially the same thing. We'll talk about the difference between what a prism and a cylinder is in case you don't know. Before we do that, I wanted to mention that I finally put a reference sheet up on the Canvas classroom, and that can be found right here at the top, Unit 7 reference sheet. It's not beautiful, but it has all the formulas that you need to know. So right here you have area at the top, and I wrote it out with full spelling and everything, but except for I didn't write radius there. But anyways, you can kind of see what to do. There's a little bit of an example. It's not, it's very functional. It just gets the job done. Now we're going to be learning volume. We have some new formulas, and we're only going to be learning the volume of prisms/cylinders, pyramids and cones, and spheres. You can actually see the formula right here that we're going to be using today. So there you go. So there are 6 formulas you need to know. In a typical year, we would learn more, but shortened school year, weird year. So we're just going to go with these 6 formulas, and we'll see how we can use those together. So let's look at this. First of all, we need to know what a prism is. A prism is a 3D solid with a constant cross section. And first, let me show you what is not a prism, which would be a pyramid. So if I start off with a triangle right here, I can draw a pyramid. All right, we will look at pyramids later, but what I want to show you, we have the base of our pyramid, which is on the ground. The base of our prism won't always be on the ground. Let me tell you that right now. But with a pyramid, the base is right here. Now, if I look at that, if I pulled this out, the cross section of this, just the two-dimensional cross section is going to look, like a triangle, maybe that big. But if I moved up higher in the pyramid and then I pulled this one out, now the triangle has gotten smaller. And if I go up to the very top, or close to the very top, then this is going to be a much smaller triangle until you get to the very top, and the very tip-top point is just a point. So we can see that the cross section changes as we move up and down the pyramid. This is not mind-blowing stuff. It's something that is pretty obvious. But with a prism, now let me draw a triangular prism. All right. So a triangular prism has a constant cross section. So again, here's the base of it. And so it looks like this triangle right here. Now, if I move up to here, we can see, okay, nothing has changed. That's still the same triangle. And if I go up to the very top, that's still the same triangle. So we can think of it almost like we were able to take a two-dimensional triangle. Let me erase everything on the screen. And let's just pretend we started off with a triangle. And we were able to somehow grab that two-dimensional triangle and pull it out from the screen in three-dimensional space. That would be a prism. Okay. So pretty clear with that, I hope, what we're talking about with prisms. Now, as far as cylinders go, cylinders are essentially the same thing, but that's, oh my gosh, that was almost the best circle I've ever drawn in my life. You guys were witnesses to that. But anyways, a cylinder, you've got a circle that is your base shape, as opposed to like a triangular prism. So when we're talking about prisms, and this is not going to be something you're quizzed on, but I might have you guys try and like speak with this language. So you name your prism based on what the base shape is. So you can have a triangular prism, like in this case we have. You can have a hexagonal prism. So let me draw a hexagonal prism real quick. In fact, one of the classes I took in college, I was really into geology, and that was my idea, was to be a geologist in life. Plans changed, but hexagonal crystals are very, very common in minerals. So a hexagonal prism would look like that. It has a hexagon for the base. So that's how you would name it. Hexagonal prism, rectangular prism, triangular prism, you get the idea. Pentagonal prism. With a cylinder, it's a circle. And there are just, it's notation reason, there are just reasons mathematically why we would have a distinction between this. These that I'm talking about, these are all what are called polygons. And this is not a polygon. So it's not technically a prism at that point. And there are maybe other reasons. Yes, you can have an octagonal prism as well. In fact, just imagine any shape. In fact, I could draw this random shape right here. And that is a polygon. Now imagine I could take that and like three-dimensionally draw it, or grab it and stretch it up in space. Then that would be a, let's see, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a non-nagonal prism. Luckily, we don't deal with that stuff. All right. So there we go. And the upshot of all this is that cylinders or prisms, we use the same formula either way. And it's pretty straightforward. So we're going to do 4 problems together, and then your homework is going to be pretty straightforward. For tonight, you don't have any super complex problems that involve trigonometry or anything else. So what we've got is, in this case, what would you call this kind of prism? Rectangular prism. There we go. And rectangular prisms are interesting, or whatever you want to call it, in that with some of our prisms, certain faces have to be the base. And we're going to see that in our next example. But with this one, it doesn't matter which one we call the base. And we've used the term base and height already, like in a parallelogram, right? We have the base right here and the height right here. But we're going to be talking about base and height as far as these are called faces of our solid. Instead of sides, they're called faces. So we're talking about the base that is the face that forms the base of our prism. Okay, so with the rectangular prism, it doesn't matter which one is our base because this one is equally the base as, the bottom is. So, I mean, in this case with rectangular prisms, it's easy enough just to look at it this way. So I've got the base, which is this rectangle on the ground. And to get the volume, what I want is I want to get the multiplication of all three dimensions of this solid. So I've got a dimension here, it's 6 across, it's 9 back, and it's 4 up. And so what that's going to create is a small collection of cubes, right? Now we're not actually seeing these cubes, but we can imagine a cubic centimeter right here. We could have a big collection of those and figure out how many of those can fit in the box. You've learned volume in the past, so you might have done stuff like this, even with manipulatives. So that's the whole idea. How many of those cubic centimeters can fit in this box? And that's going to be 1 by 1 by 1. You might not be able to see those numbers that I just wrote in. And so to do that, I just need to multiply my three dimensions together. But let me break it down a little bit more. What we're essentially saying is that our volume formula for a prism or a cylinder is the area of the base times height of the prism. And with the area of the base, I need to figure out what my shape is. In this case, the area of a rectangle, which is just base times height. And this is where it gets a little bit confusing because we are going to use base as both a face of our prism and the base as in the side of a shape. So you kind of just need to keep that straight. We could come up with different terms, but honestly, these are terms that show up a lot in geometry. So if you ever have to do stuff like this again in another class, it's good to just be aware of the terminology. So the base of this, so this is pretty straightforward. If I took this rectangle and put it out here, that would be 6 by 9 centimeters. So that's going to be 6 times 9. That's pretty straightforward. It's 54, and remember, it's square centimeters. So now I can take this 54 square centimeters, which is the area of my base, and I can plug it into this formula for that. So let me go ahead and put the volume here is going to be 54 centimeters squared. Now, what's the height of my prism? In this particular problem, what value would be the height of the prism? 4. So the main idea behind the height of a prism, okay, and there was a question in the chat. I'll come back to that in a second. But because we're calling the bottom of this down here the base, we want to find the dimension that is perpendicular to it. So this 9 times 6 is 54 square centimeters is sitting flat on the ground. So this 4 is perpendicular to that length. So now what I can do is I can multiply the 54 times the height of the prism. In this case will be 4 centimeters. And now we can do that math. What's 54 times 4? 216. There it is. And what's our unit going to be for volume? Centimeters cubed. There we go. I kind of mentioned it, but then I kind of glanced over it. So yeah, with centimeters cubed, we're saying we have 3 dimensions that we're measuring. So we're measuring space now, not area. And space is measured in cubic units. All right, now this was a question I think it's worth talking about. It's why didn't we do 6 times 4 to get the base? And well, and with this particular problem, this is one where we have the freedom to pick which is our base. So I could have decided that this side right here that's the closest to us is the base. There's nothing wrong with it with a rectangular prism. With the next one, we can figure that out. We can see that sometimes we don't have the freedom of decision. So in that case, I could have done 6 times 4, and then once I had that, then 9 would have been the height of my prism. All right, and I do want you to see it this way. You might be thinking, why don't we just use this formula? Length times width times height. We're not going to come up with a different volume formula for each prism. We're going to use the same volume formula for each prism that we have, and we'll see how that applies with the next example. All right. So my first question is, what kind of prism is this? It is a triangular prism. And this is one, this is where it can get confusing. And I will tell you right now, triangular prisms are the ones that cause the most problems. And I can kind of understand why. But notice that what a lot of people are going to want to do is they're going to look at this side right here that's sitting flat on the ground. And they're going to say, oh, that's the base. It's a rectangle, therefore it's a rectangular prism. Except it's not a rectangular prism. The base is not just whatever side is on the ground. The base is whichever side has a constant cross section the entire way. So notice this base right here doesn't have a constant cross section. It looks like, you know, this sized rectangle down at the bottom, but then if I move up higher, it's going to look like that. If I move up even higher still, it gets to be this really narrow rectangle. So it's not a constant cross section the entire way. So that is not my base. Now on the flip side, if I consider the triangle to be my base, then I can draw the same triangle everywhere along the way. So that's the base. And that's what you kind of need to be training your brain to be on the lookout for. Which side, when I put it on the ground, will have a constant cross section the entire way up. So you can actually, what I like to do is imagine that you could grab this thing off the screen and hold it in your hands and set it down on the ground. If you can set the base of this on the ground, then what would we consider the height of our prism? So the base in this case is the triangle. If I could put the triangle flat on the ground, then what would the height of it be? Oh, that's not very pretty, but so imagine now I could put that same triangle flat on the ground. So now what is this length right here? 9. Yeah, 9. So that's what and that's just to get you to think about what's the height of your prism. Now the formula that we constantly are going to use here is the area of the base times the height of the prism. And what I use different variables for that. I use capital B sometimes. I can actually write out area of the base. But capital B, if I use that, that means the area of the base. That doesn't mean lowercase b, which is like the base of a triangle, which I might put right there. So area of the base times the height. And when I say the height here, I'm talking about the height of the prism, height of the prism. So knowing this, what values can we already put in? Well, I could put in the 9. What would the 9 be? The area of the base or the height? The height. So I can already plug this in, 9 meters. What I don't know yet is the area of the base. And this is where we have to come back to our volume formulas. Sorry, not volume, our area formulas. So you learned 3 of them, and the area of a triangle we learned is base times height divided by 2. And I'm just writing it that way because everything I've seen is people prefer it like this. So we're good with it. So area equals base times height divided by 2. But now keep in mind, we're talking about a different base and height. And this is where it can get confusing, but you just need to keep track of it for yourself. And I'm going to take this triangle that forms the base, and I'm going to draw it separately. You don't have to do this for your own work, but I just want to show it here. So I know that this is 6 meters, and that's the right angle. What is this side at the bottom going to be? It will be the base. Do we know the length of it? If you had to guess, what would you guess? Also be 6, and it will. And the reason for that, remember, it's the same triangle the entire way through. Notice at the back, maybe it's getting lost in all the drawing, but at the back of this, it's showing that these two sides are congruent. So if they're congruent at the back of the triangle, that means they're congruent at the back of the prism. That means they're congruent at the front of the prism. So if this is 6, then this side right here is also going to be 6 meters. All right, is that making sense? So now we can actually plug this in and we can find our area. 6 meters times 6 meters divided by 2 gives us a volume of what? Squared. 18 meters squared. We have to start by solve. Well, I'll kind of come back to that, but we do have to solve for the area. And once we have the area, we can plug it into this formula right here. And now we can multiply the area of the base times the height of the prism to get our final volume. And we know it's going to be cubic meters. So I'll write that in, but you guys can put in the number or tell me what you get. 162. We got 2 people getting that same answer. There we go. 162 cubic meters. And yeah, that's the process. So let's go through. We have 2 more to go through, but I want to kind of let you guys do more and more of the work as we go through. All right. So for this one, what kind of prism are we looking at? Okay, it's another triangular prism. Just as a reminder, don't look at what's on the ground. Look at what has a constant cross section. And whatever face has a constant cross section, that is your base. So now I have to do volume equals, I'll go ahead and show you this one, area of the base times the height. So what area formula do we need to use? There it is, base times height divided by 2. And you can kind of start doing this work in your own order. But what I always like to do is I start with the volume formula because we're going to learn multiple volume formulas. And it's not always going to be the same thing. So now that I've established that it's a prism, I'm going to use this formula. I'm going to start with that. That's going to be on the screen. And now let's start by filling in. And I'm just going to put this right here. Fill this in with information we already know. Okay, 14. So, and here's a good thing. It doesn't matter if we put the height for 8, like if it goes right here, the second number, or first. We're multiplying them together, it's going to be the same. So 14 centimeters is going to be the height. So just to make sure it's really clear, that's there. And there's no problem to flip those around. So now we just need to solve for the area of the base. I'll just write in the unit real quick. So now you have your formula. I'm going to stop doing this work for everyone. I want you guys to solve for the rest of the volume from here, and then we'll go through it in just a few minutes. So with this, we knew the height of the prism. Now we need to find the area of the base. And maybe I should have, instead of calling this A, I can put a capital B here so that we know that this gets substituted in for that right there when we're done. Okay, but not a big deal. So now we're looking at this triangle. And with this particular triangle, if I look here, just like we talked about last time, if it's 10 right here, it's going to be 10 at the back. If this is 8.3 right here, this is going to be 8.3 up at the front. And the other thing to keep in mind is that when we're looking for a triangle, let me just draw the triangle separately now. When we're solving for the area of a triangle, it's important we use two dimensions that are perpendicular to each other. We can't use the 10 and the 10 because they are not perpendicular. Oh, okay. Okay, then that makes sense why you're getting what you're getting. I was like, that's a very big number. So yeah, the 8.3 does look a little bit like 83. Now at this point, we are dealing with a height of 8.3, and this is the height of our pyramid. Sorry, oh, that was a mistake. The height of our triangle. So the height of our triangle is 8.3. The base of our triangle is 10. So now I can do this. 10 times 8.3 divided by 2 will give me 41.5 centimeters squared. All right. And that's probably where, of all the people who miss it, 95% of them will make a mistake in that step right there. But once you have that, then it's pretty straightforward. I'm going to take that 41.5 and I'm going to plug it into this equation. So if I can, I'll just bring this down real quick. So the volume is going to equal 41.5 centimeters squared times the height of our prism, which is 14 centimeters. And that gives us the 581 cubic centimeters. All right, you guys feeling okay with that? All right. So let's look at one more. And maybe what I'll do with this problem is I won't even give you, how about I only do this? I'm just going to put that the volume is going to equal the area of the base times the height. Yes, it is a cylinder, but we don't change our volume formula based on that. It just changes the name. So from here, see if you can figure out what the volume of this is going to be. Oops, didn't mean to do that. So we can see 4 different responses here. I bet even more at home and elsewhere in the classroom. Kind of align to say 503 cubic meters or meters cubed, however you want to say that. So what we're looking at is a cylinder. We can see it's the base of this is a circle. So if we are filling in what we already know about this, I'm just going to run through this because you guys are getting the answer. So we know that the height of this cylinder is 10 meters. So I can just go ahead and have that. Now, knowing that we need to get the area of the base is going to be the area of a circle, which is pi r squared. And the radius is given right here. So it's going to be pi times 4 squared. And when you do this, you're going to get 50.265 ... And so what everyone here did is they just rounded that to 50.3. The one thing I might recommend, though, honestly, this is good. You have a good answer. Sometimes, just in general with problems, if you have a multi-step problem, you're frequently told, don't round until you get to the very end. So when I say don't round, that means keep maybe a longer number. So 50.2654 or 2655 really. So only round when you get to the end. But having said that, this isn't a problem for me right now. So whether you plug in 50.3 or 50.2655, you will multiply that out. And the only difference that's going to happen is in this case, I'm going to get 50 or 502.655, which rounds to 502.7. So not centimeters, it's supposed to be meters. So we're talking about 3/10 difference. If this is a test, I would have accepted this, but for more precision, don't round until you get to the very end. But that's the only thing here. You guys did the process correct. Everything looks good. So let me clear this. And your homework is just a PDF with more practice problems. So if I show you this real quick, I just want to point out that in your homework, here it is. There it is. No, I don't know how that happened. Sorry. There it is. Okay, in this homework, there's going to be some problems that have red boxes. So you want to do the ones with the red boxes. And notice I showed you there's hexagonal prisms. You can see one right there. There's a pentagonal prism. To solve for those is a bit more involved, and we're not going to do that. So you can skip those completely. But you have cylinders, rectangular prisms, triangular prisms, and that's about it. So you can practice with those. You don't have to do any extra trigonometry or anything along the way to solve for your missing values. They're all going to be there. The only other thing that's going to be a little bit of a challenge is these two down here are word problems where they don't give you the diagram, and you're going to kind of need to draw that in order to figure it out. So when it says it's a cylinder, well, you can use this as a template, and maybe you could just take these values and superimpose them on this cylinder until you have a diagram to work with. But anyways, you can figure that out, whatever works for you. If you have questions on this, if you are not able to figure out 11 and 12 or any of these other ones, just let me know. And we can certainly go through those problems. I did include the answer key at the bottom so that you guys can check your work as you go through. But make sure you're doing this work, getting the practice in. So with that, I have said enough. We're going to practice more with prisms and cylinders on Monday. So do this, and once you're done, you can relax. Have a wonderful weekend. I will see you guys on Monday. Stick around if you have any questions, but otherwise, have a good one.